Hello and welcome to the surface area of cones. So I've drawn a cone here and I'm going to show you the important dimensions. And first of all, every cone has a circular base. So it's going to have an important dimension, the radius. Every cone has a certain height. And we're talking about the height directly from the bottom of the cone to its highest point, so perpendicular to the base circle. There is another dimension that is important, and it's called the slant height, and that is from the highest point of the cone down to the outer edge of the base circle. Okay, those are the three important dimensions, and there is a formula for the surface area of a cone, and that formula looks like this. First of all, if you're including the base circle, we would want to see pi r squared, which gives us the area of that base circle. Then we're going to add to it the area of this rounded part, also known as the lateral area. So we're talking about this rounded part of the cone. The formula for that is pi times radius times slant height. So this part here is actually the lateral area. And when you combine it with the base circle, we get the total area. So that's the formula that we use for cones. And now we're going to go ahead and do an example. So I'm going to clear this off, give myself a little bit more room to work with, and do an actual numerical example. Alright, so there's a cone, and I think we're going to put in some lines here. So let's say we have a height and a radius, and let's say that that height is 16 centimeters. And let's say the base radius here is 10 centimeters. And we'll just fill in the rest of this so it looks a little bit more clear. So there's our cone, and we're looking for the lateral area. So we take our formula and we say, hey, I don't want this part of it, so I'm going to tweak my formula a little bit. I'm going to throw this away because it says lateral only. So I only want the pi r times slant height. And so I'm going to go ahead and say, well, that's my formula. I've got pi times a radius of 10 and a slant height of, oops, I don't know. So now how do I get the slant height? So looks like we got a nice little right triangle, and I'm going to use Pythagoras' theorem. So over here we're going to do a little bit of prep work. We're going to go ahead and say slant height squared equals 16 squared plus 10 squared. Now I went ahead and I squared 16 and I squared 10 and I added them up and got 356. So now all I got to do is square root that number. Okay, and I'm just going to leave it as an exact number. You can turn it into decimals if you like. If you do that, though, keep about 3 decimal places. So there it is. Now all I got to do is put all that through on the calculator, which I've already done. And if I write my answer rounded to 2 decimal places, I should get 592.75 square centimeters. Okay, so that's my first example. I'm going to do one more. Sometimes these questions have you kind of working backwards. So let me show you what that would look like. Okay, so in this example, we might be told the total area. Total area of a cone is 1,131 square centimeters. And we're asked to find the slant height. So find the slant height. Okay, so what we're going to do is we're going to take our formula, and we know what the total surface area is, and we're just going to plug everything that we do know into this particular question. Oh, there's one more thing I didn't tell you. That's kind of important that we know. They're going to tell us the radius, because if we don't know the radius, we're in big trouble. Okay, so that's still part of the given information. So let's put all the given information into the question now. So there's my total area. I want to keep the base circle, and I know the radius is 12, plus pi times that base radius times the slant height. So how do I solve this for s? Because that's the one and only unknown. Well, let's make one calculation pretty easy. We can go 12 and square it and times that by pi. When I did that, I got 452.389. Then I went ahead and I went 12 times pi, and I got 37.7 times s. So next thing I'm going to do is I'm going to subtract this extra number here to get rid of it. So I'm going to subtract it from both sides. So on the right side, I've got 37.7 times s. On the left side, I've got 678.611. So now to solve for s, I'm going to go ahead and divide both sides by 37.7. And when I do that, these cancel and I'm left with the slant height. So the answer I got was 18.00 centimeters as the slant height. So with that, I'm going to stop, and we will catch you later.